Welcome everyone. Now today we'll start off with our first worksheet, and in this first worksheet it helps us to get a basic understanding about intervals and its corresponding subintervals. And you will see that these are very useful. This knowledge is very useful when it comes to integration, and we will go through those required details later on. Okay, so in the first question they ask us to give a formula for the right endpoint of the ith subinterval. Okay, let's see how we are going to do it. Now here we have the first main interval AB. That means in the real axis we have 2 points A and B, and this can either be positive or negative, that doesn't matter. Okay, right. And then they have told that ith subinterval for a general n. What do we mean by a general n? That means this interval is divided into n parts, n equal parts, or in other words, this length, the length b minus a, will be divided into n equal parts. So the length of a single part will be b minus a divided by n. Now, and this length of a single segment, we have a standard symbol, that is delta x. We use delta x to represent the length of a small segment, right? So now in this case, if we were told to divide this interval into n equal parts like this, right? Now we can divide it into any number of equal parts, and the length of this one is represented by delta x, which will be equal to b minus a over n. We will do some explicit example, we will do a particular example after this theory. So for the time being, they are asking to write a formula for the right endpoint. Now, what do we mean by right endpoint? In this subinterval, now this is our big interval AB, and these are the subintervals. And when you take a subinterval, if I take this subinterval and if I enlarge it like this, because then it will be easy for me to draw the things. So this is that small subinterval, right? And the endpoint towards the left is the left endpoint, and this will be the right endpoint. And in the question, we are told to give a general formula to write down the particular value at the right endpoint in here. So that means at the initial stage we are starting off with A, right? And then this will be our first subinterval, and this will be our second subinterval. Likewise, it will be the third, fourth, fifth, sixth, seventh, eighth. Likewise, we can keep on doing that until we reach the last subinterval. And as we divided this whole thing into n equal parts, that means we have divided this length into n equal subintervals. So there will be n subintervals. For example, if n is equal to 10, we will have 10 subintervals, right? And then if I choose a general number an arbitrary number, and if I call it as I, or in other words, if this is the ith subinterval, I is just a number, right? How are we going to determine the position of this right endpoint? Let's see whether we can come up with a general solution for that. When this is A, the left endpoint is A. And we know that in order to reach this point, this first landmark, we should travel a distance delta x, because delta x is the distance of a subinterval. Or in other words, we can say if we add delta x to A, you can reach this first landmark, right? That means when you add delta x to A, you can reach the first landmark. And if I say it in a different way, this is our first subinterval and this is the right endpoint of the first subinterval. And then, how about the second one? If we need to reach the right endpoint of the second subintervals, what is the distance that we should go starting from A? We should pass this boundary and we should reach this point. That means we should travel a distance of 2 delta x's. This is delta x, this is delta x. So we have to we have to travel a length of 2 delta x's in order to reach the right endpoint of the second subinterval. How about the third one? We should travel 3 subinterval distances. In other words, 3 delta x's. So in the same sense, how about the ith subinterval? If this is the ith subinterval, that means we have to travel I number of delta x distances in order to reach this point. Okay, so if we are to write down the formula for the right endpoint of this ith subinterval, it is simply starting from A, we should travel a distance of delta x times I. So this will be the formula of the right endpoint of the ith subinterval. Now how about the left endpoint? How much distance do we have to travel to reach the left endpoint of the ith subinterval? Now if we reduce down to a particular example or a particular value for I, if this is the second subinterval, it is enough to travel 1 unit of delta x, because in order to reach the left endpoint, it's just, in other words, it's the right endpoint of the first interval. Or if I say it again, the left endpoint of the second interval is the right endpoint of the first interval. Left endpoint of the third interval will be the right endpoint of the second interval. That means the left endpoint of the ith interval will be the right endpoint of the I minus 1th interval. So, according to the formula that we derived, how much distance do we have to go starting from A in order to travel the left endpoint of the ith interval? Or in other words, how to reach the I minus 1 subinterval right endpoint? It will be I minus 1 delta x. This represents the right endpoint of the I minus 1th interval and left end point of ith interval.